Okay, we're going to take some notes for Chapter 2, Section 3. Have your Chapter 2 note packet out. We'll get through these notes. Short assignment, hopefully be done in no time. Okay, from some previous material, just a quick little review of what we're talking about here. Remember, we've got state whether this is linear. This has an x squared, and therefore it's not linear. Not linear. This would actually be quadratic. This would actually be a parabola that's opening up 2 units up. We're going to have a whole chapter on parabolas. It's going to be great. State whether this is linear. This is in standard form. Remember standard form, ax plus by equals c. And therefore, yes, this is linear. Yes, linear. Okay. Point symmetry or line symmetry. We have a point at 0, 2. This would rotate 180 degrees. If I flip this upside down, it would look exactly, or if I rotated this 180 degrees, it would look the same. I would say point symmetry at 0, 2. And then down here, I've got line symmetry, and I'm traveling through the vertex of that parabola. It's being cut in half. I could fold it on top of itself. I have line symmetry at x equals -1, -2, -3. Line symmetry at x equals -3. Okay, function notation using a calculator. Grab your calculator, and we're just going to plug and chug here. The volume of air in lungs during a 5-second respiratory cycle can be modeled by this equation. That's a nasty looking equation, where V is the volume in liters and T is the time in seconds. This model is an example of a polynomial function. Find the volume of air in the lungs 1.5 seconds into the respiratory cycle. So volume at 1.5 is equal to -0.037 1.5 cubed plus 0.152 1.5 squared plus 0.173 times 1.5. So we're just going to plug and chug, but we really kind of want to know what is our answer here. So again, remember, this is the input, and now this will be the output. So our volume at time 1.5 seconds, if you plug that in, 0.476625. And what are we talking in? We're talking in liters. Liters. So that's how much you could expect in your, so as time goes by, that's how much air you would expect in your lungs during that time. Okay. Big thing for today, writing and behavior. Writing and behavior is something that will definitely come up in future math classes, and we'll use it throughout this math class. So what we want to think about is in the long run, end behavior, at the end of the road. If I go all the way out to the right, where does my graph go? And all the way out to the left, where does my graph go? So as my x's get bigger, so this is how we're going to write this. We're going to say for number 1 here, I'll do this one over here. We're going to say the limit as the x's go all the way to the right, all the way to infinity. Where do my y's, which I'm going to call my f of x's, where do they go? And we're going to say, as my x's get bigger, the y coordinates go down. Go down where? Go down forever to -infinity. So this is how we're going to write it. You read it, the limit as x approaches infinity, this is where my graph goes. And then I'll say, I have most of the time we are going to have 2 of them. And then the limit as I go out to the left. Well, where are you going to the left? You're going forever to the left. Where does my graph go? So as my x values get smaller, my y values are also getting smaller, and we are heading towards -infinity. So we are going down and down. Next. I can't make that work. Next, let's change the color. Let's go with a little blue. Great. Now, I'm going up and up in the long run. I'm not worried about locally here. I'm worried about as my x values get bigger, where the limit as x heads all the way out to the right, where does my graph go? My graph goes up to positive infinity because it's going to finish up. The x values are getting bigger, and on the ordered pairs that satisfy the equation are also getting bigger. And now I have the limit as x approaches infinity. Where does the graph go? This should be negative infinity. Almost made my first mistake of the year. I am going up again, okay? So as my x's go out to the left, where does the graph go? The graph goes up. Now we've got a little staying alive here, up to the right and down to the left. And now, oh, I should change I'm going to change my color again, you know, for effect. Let's go with, green. The limit, I bet you guys can't even read that in the back. As x approaches infinity, where does the graph go? The graph goes up. Up to what? Up to infinity. So I'm going, the x's get bigger, the y's are getting bigger. That's because we're heading up. The limit as x approaches negative infinity. As my graph goes to the left, my x values go to the left, I'm going down. Down to what? Down to negative infinity. Okay? And let's get a better color there. Let's see if we got something better. How about gray? I don't know if I've ever used gray. So I've got up here, down there. So now I say my limit as x goes out to the right, the graph goes down to negative infinity. And then I'll say the limit as x goes out to the left, my graph goes up to positive infinity. So you're looking the end behavior in the long run. In the long run. Okay. This one looks a little bit different. Describe the end behavior. So I'm going to say, let's get a different color. I'm going to say, I kind of like that blue, you know, go Sabres. The limit as x goes out to the right. As we go out to the right, here I am at 1, negative 1.5, 2, negative 1.5, 3, negative 1.5, 4, negative 1.5, 5, negative 1.5, 6, negative 1. I'm going to be doing that forever. So I'm actually, I'm actually going, my function is actually not even approaching. I could say equal, but I think we're going to go with the arrow here. Sometimes we do an equal, and that's okay. But we are heading to negative 1.5. We're going to stay at negative 1.5, and I could say the limit as x approaches negative infinity. As we go out to the left, where are we going? My f of x is going to negative 1.5, because that's where I'm going to stay. It's going to be, we go out to the right, we're going to stay at that y value of negative 1.5. So that's end behavior. In the long run, what will we approach? And we'll work with that throughout the class, and it'll get a little bit funky when we start into some asymptotes, but that's for a later date. All right, location principle. I like to talk about the location principle. One of the great ways we can talk about that is if this is the Mississippi, Mississippi. In order to go from Sartell to, wait for it, Sauk Rapids. What do you have to do if you're going from Sartell to Sauk Rapids? You gotta cross the river, right? Whether you choose to go in a boat or over the bridge, right? Or you could drive up to Rice and go over the bridge, or you could go down to St. Cloud and go over a bridge. Yeah, I know. You could drive north of Itasca State Park and come around, but that's probably not going to be very effective. Okay, so here's what the location principle says. If we think about this is the river and Sartell down here and Sauk Rapids down there, the only way that you can go from a negative y value to a positive y value greater than 0, positive. The only way you can go from a negative to a positive is if you pass through 0, okay? The only way I can go from Sartell to Sauk Rapids is if I pass over the Mississippi River. The only way I can go from a negative y to a positive y is passing through 0, okay? There has to be a 0 when I go through it. All right, so here's what we're going to do. We are going to determine the number of zeros on the graph. What we're going to look for, this is my x's, this is my y's. We are looking for when the sign changes from a positive to a negative. We have to have a 0 there. From a negative to a positive, we have to have a 0 there. Okay, on the I'm talking about on the y values. I should probably put those over here. I don't want you to get confused. Why do I have such a hard time with that? Eraser. I'm going to erase these, and I'm going to put them over here for effect. All right, it's going to be great. Okay, so this has got to be a 0 because the sign changed. There has to be a 0 in here because the sign changed. Positive to a negative. There has to be a 0 in here because the sign changed. Negative to a positive. Notice there's no sign change there, so we're not sure. We're pretty sure it doesn't. And we got a 0. So we come over here and we look between -2 and -1. There is my 0. -1 and 0. There is my 0. Between 0 and -1. There is my 0. So we're going to talk about in between x equals 2 and x equals 3. There is my 0. Okay? So we are going to look on our calculator. We're going to utilize our table, and we're going to find our zeros. Okay? We're also going to look for relative maximums and relative minimums. And those are just going to be high points. The graph is increasing as it approaches, and decreasing and go away. You got high points. That's going to be a maximum. Now, it might not be the absolute maximum on a graph, but that's why we say relative or local maximum. It's the highest point in the area, okay? And then you've got relative minimum, all right? Think about going to the top of a tower on a large hill that they have those where they used to spot the fires from, right? Oh, here's a hill. Oh, they put a tower on top of it. Why did they put it up there? Because it's a relative maximum for the area, and you can look around in 360 degrees, and you're looking down in all directions, right? And then turning point, it's where we turn from going up to going down, or maybe we turn from going down to going up. So we got a minimum there, we got a maximum there. And we can see those on a graph too, because here we go. I'm up at 9. I'm down, I'm at a high point here. I don't know what's happening outside of that. And I go down to 0, down to -1, up to 0. So I bottomed out, right? So this has got to be a minimum. 0, -1, 0, -3. Okay, so I was at a bottom of minimum of -1. I went up to 0 and down to -3. So I went up to 0. That means this is probably some sort of maximum. Down to -3, down to -16, down to -45. So the only thing I can tell here is I have a minimum here and a maximum there. Let's find some zeros now too, shall we? So we want to find the zeros and we want to find the max and the mins. So I'm going to get my blue pen out and I'm going to say I went from, well, this is a 0. Okay, so sometimes they land right on them, no big deal. And this is a 0. So I would say I have zeros at what? They're actually at points. Don't at me. X equals -2 and x equals 0. And then I got a minimum at -1, -1, and a maximum at 0, 0. Let's plot a couple points. -2, 0, -1, -1, 0, 0, 1, -3, and then I had, what else did I had? I had -3, -9. I'm somewhere up here. So we're coming down, minimum, maximum, and going down. And there you go. So we are identifying this stuff from a table, okay? So we can find these things right off of a table. grab your calculator. We are going to graph the function by making a table of values. We are going to determine the consecutive values of x between where each real zero is located, and we're going to estimate the max and the min. So I'm going to grab my calculator, and we are going to type into y equals, we are going to clear out our stuff from last section. We are going to turn my plots off so that I'm in good shape. Remember, you can just go up. So I've got 0.75x to the fourth, scroll to the right, plus x raised to the third, scroll to the right. Remember, you got to know your calculator. Minus 3x squared, and the squared is automatic, plus 4. I'm just looking at the table. When I look at the table, I'm going to scroll up, and let's see. I think we can capture everything. So if I was writing on your sheet, on your piece of paper, you should go from -3 to -2 to -1 to 0 to 1 to 2. So those are really the ones we want to capture. All right, so when it says, what are my points? I've got, I have a 0 between -3 and -2. And then I go from a positive 10.75 down to -4 up to 0.75. So I have a max, or excuse me, a minimum at -2, -4. I'm down at -4. I'm up to 0.75. I'm up to 0.4. So I'm up to 0.4, and then I'm down. So I was 0.75, positive 4, 2.75. So I have a max at 0.4. Okay, and then I have down 4, 2.75, 12. So I'm down. I'm at a min at -1 and 0.75. No, a minimum at what? 2.75. Sorry, 1 and 2.75, and then I go up forever, up to 212. So if I'm going to graph that guy, I'm going to think about the following. I've got a 0 between -3, 1, 2, 3, and -2. I've got a minimum at -2, -4. I've got a maximum at 0.4. I've got a minimum at 1, 2.75, and then I go up forever. So now my sketch is going to look something like this. This is a sketch. Wait, -3, -2. I gotta have a 0 somewhere else, don't I? I gotta have a 0 between -2 and -1. So, and -2 and -1. Okay, let's get that. 0 between -2 and -1. Yeah, because I got to come up here, right? Because I got to go from negative land back to positive land. And now I got a minimum. So I can see all the stuff that I wrote. Okay, so you should write, what, -3, -2, -1, 0, 1, 2 in here, and then the corresponding y's. So the important ones were a 0, and that was between x equals -3 and x equals -2. And then I had another 0 between x equals -2 and x equals -1. And then I had a minimum. I have a minimum at, x equals -1. So it's at a point. What did I get? I got -1 and, or -2, excuse me. -2, -4. I found it. -2, -4. And I've got a minimum at 1 and 2.75. And I had a maximum at 0.4. So again, I had a minimum here, and I had a 0 between these two, a 0 between these two, a minimum there, a maximum there, and a minimum there. And there I just plotted those points out. Okay? So we're finding the zeros, and we're finding the minimums, and we're finding the maximums. One more. Plug this into your calculator, fill these guys in, and then we're going to find the important stuff. So I'm going to plug this into my calculator. Clear that out. Remember, a negative sign needs to be this one down here. X to the third. Scroll to the right. Plus 3x squared. Whoa, that's not a squared. Almost made my first mistake of the year. Minus 3. And then we're going to get the table. And I think they had us write in negative 2, 17, negative 1, 1, 0, negative 3, 1, negative 1, and 2, 1, and 3, negative 3. Okay, so let's fill those suckers in, and then we'll go from there. Negative 2, 17, 1, 1, 0, negative 3, 1, negative 1, 2, 1, 3, negative 3, and 4 was negative, negative 19, so we are fine there. So negative 2, 17 way up there. Negative 1, 1 here. 0, negative 3. So I had to have crossed through a 0. This would be a 0 between negative 1 and 1. And then I go up to 1, negative 1. And I go up to 2, 1. So I've got a 0 in here, don't I? And then I've got a 0 in here, don't I? Because I went from 2, 1 to 3, negative 3. I'm crossing the river. Crossing the river. So my sketch comes down, goes up, and comes down. So let's see what happened here. I've got zeros between, and we say between x equals negative 1 and x equals 0. I'm crossing the river. I'm crossing the river again at between x equals 1 and x equals 2. I'm crossing the river one more time between x equals 2 and x equals 3. Those are my 3 zeros. I've got a minimum at 0, negative 3. That's right here. I've got a maximum at, what was that, 2, 1. Again, we're looking for, I'm looking for smallest values and largest values. And my lowest value was 0, negative 3, minimum. My highest value was at 2, 1, maximum. So I can visually see my 3 zeros, and they happen in between things. If it falls right on it, just say right at the point. But if they're in between, then that's what we say. Okay? That's it. I know that's a bunch, but it's a little calculator work, and you're making a table, and everything's going to be A-okay. Here's your homework, page 108, and we'll find that important stuff, and you'll sketch some graphs.